Alright, so for page 2a, we're looking at mostly fractional distance. Same stuff we've been doing, except now we're doing it in 2 dimensions. So in blue, I'll do my x direction, and in y, we'll have, in red, we'll have the y direction. In blue over here for the x, if I first plotted my points, I'm literally looking at negative 2, 1, which is right here, all the way over to 4, 7, up here at the top. Connecting these two lines, really the goal of this problem is to travel 1/4 the distance across this line from this point to this point. If I'm doing this in the x direction, that'd be this way, that'd be my blue line here. And really the goal then is to travel from negative 2, if I think of it like a number line, from negative 2 to 4, and I want to go 1/4 the distance of that. So all the way across, negative 2 to 4, that is absolutely 5, negative 2 minus 4, which is 6. And then of course, 1/4 of 6 is 3/2. Right, so if I'm traveling 3/2, I could do negative 2 over 3/2. I'm starting at negative 2, moving over in the positive direction to 4 plus 3/2, which would be negative 1/2. There's my x direction. Same thing for the y over here in red, we'll do the same thing. I'm traveling this way. So right here I've just decided, sorry, maybe I should say, we're going up to negative 1/2. That's the direction here. In the y direction, the same thing. This way. We're going to try and get the same point here for 1/4 of the distance. To do that, we'll start with 1 and travel over to 7. The distance between 1 and 7 is again 6. 1/4 of 6, which is of course 3/2. If you don't know that, just put it in the calculator, no big deal. Or you can always use decimals as well. Decimals are fine. And then I'm starting at 1 plus moving over 3 over 2, which is equal to, now I know that 1 in 2's is 2, so it's going to be a total of 5/2 for this fraction. And then 5/2 is my y coordinate. So my final point here is going to be right here over negative 1/2 in the x direction, and then up. Let's see if I cut these into halves here. You guys can see here, I'll cut these into halves. You guys can see it's 1, 2, 3, 4, 5 of those halves up, which is exactly what 5/2 mean. Pretty cool. So at this point we selected must be negative 1/2 in the x direction and 5/2 this way. Guys, it's totally okay to use decimals here if you want to use decimals instead. Alright, similar thing for number 2. We want to find 2/3 the distance from negative 3, 4 to 9, 14. If I want to do the x over here in blue, negative 3 to 9 is 12. Please ignore the dog. 2/3 of 12, which is 8 here, and I'm going to move over negative 3 plus 8, which is 5. So that's my x coordinate. And I'm going to do the same thing for the y direction over here in red, from 4 to 14. 4 to 14 is 10. And then taking 2/3 of 10 is 2/3 of 10, which is 20 over 3. And then I want to start at 4 and then move over 20/3, which is 32 over 3. Just because 4 times 3 is 12, 4 times 3 is 12, and then plus 20 would be 32/3. All right. So for my final point, it's going to be 5 for my x direction in my work in blue. And then my work in red, we got 32 over 3. Guys, if you wanted to put this as a again, decimals are totally fine. I just like fractions. They're a little more precise. And they'll help you more in algebra later down the line. So, what point is 3/7 the distance from 10, 25 to negative 3, negative 30? So same thing here. I'm doing the exact same business we've been doing. My x direction. I want to go from 10 to negative 3. So I'm really going backwards. Notice in this problem, I'm going from 10 to negative 3. I'm going backwards. I want to go 3/7 the distance, which is 3 over 7. To do this for the x direction, I'm going to first find how far they're apart. Looks like they're 13 apart. Okay, then I want to take 3/7 of 13, which is 39 over 7. And then I want to move back from 10 backwards towards negative 3, which is minus 39 over 7. 10 times 7 is 70. 70 minus 39 is 31 over 7. All right? So there's my x-coordinate. And the same thing in the y direction. I'm going to do something very similar. I'm going from 25. Oops. From 25 to negative 30. So I'm going backwards again. Negative 30 to 25, the distance they are apart, that's 55. And then 3/7, the distance of 55. 55 times 7. I'm sorry, 3 times 55 is what I meant to say. Is 50 times 3 is 150, 165 over 7. If you don't know that, just do it in your calculator. No stress, all right? No stress. I'm just working quickly so I can show you guys a practice. If you don't know that, that's okay. Just do it in your calculator. Do it on Desmos or something. And then I'm going to move over from 25. I'm subtracting 165 over 7. Let's see, 25 times 7, which would be 175 minus 165 is 10 over 7, 10/7. Very nice. So, for our final problem, our answer should be 31 over 7, comma, 10 over 7. Guys, this is the absolute hardest this problem can get. If this problem is tough for you, don't worry. This is the absolute hardest this problem can get. Don't worry about number 4. It was a bonus for the game we played, so don't worry about number 4. But if you did want to know, if you did want to work it out and try on your own, the solution will look like a plus p over q times c minus a, comma, b plus p over q, d minus b. So this is a point. Here's your x coordinate. Here's your y coordinate. That looks like that on both sides. So if that's your solution you get, good job. That'll be it for this one. See you guys on the next problem.